Hi, welcome to part two. Thanks for joining me. Um, in part one, we just had I did a brief introduction to predictive processing and the two books that I'm sort of basing these videos off: Surfing Uncertainty by Andy Clark and The Predictive Mind by Jakob Howe. And in that first video, we're just talking about how the brain, under this theory, the brain is seen as an inference machine. It's seen as something that's constantly making predictions and updating models that it has about the causes out there in the world. And I alluded to the mechanism in this video. I'm going to talk a little bit about how the brain actually does this. I'm not a mathematician, but I'm going to do sort of a brief introduction to Bayes' theorem, as is explained in the book, because it's important to understanding predictive processing. Predictive processing posits that the brain utilizes a method that uses Bayes' theorem to update the probability of a hypothesis about the causes out there in the world as more evidence becomes available. So I'm going to run through sort of like an example in the way that it was explained in the Predictive Mind to kind of understand a little bit about Bayes and how why it's important and why it's useful to know about this. So imagine you are a person trapped in a box or just a house, just a wooden house. You're in the room and you hear a loud but muffled, ambiguous sound. Now this sound is the evidence. Okay, you can come up with a number of hypotheses straight from the start. It could be your neighbour that's come round, he's knocking on the door. It could be a football kicked by some children. It could be a tree that's fallen against the wall, or it could be, this outlandish sort of idea of a small UFO that's crashed into the house. So there's many things that it could be. That there are many different causes for the same effect on our senses. So the next thing to consider is the likelihood, and it's used a little bit differently than its sort of common usage, the word here. But this is the probability of the effect you observe, given that the particular hypothesis that you're considering is correct. So in this case, a UFO landing and hitting against the house or a tree might actually have quite a high likelihood because the UFO or the tree would actually sound very much like the muffled sound that you heard. So it's basically a way of considering the probability that the effect that you hear could actually be caused by your hypothesis, if your hypothesis was correct. The next thing to consider is the prior probability. So this is a subjective estimate of how probable each one of your hypotheses are independently of the effects you're currently observing. So, in this case, the neighbour coming around and knocking on your door or a football being kicked seems much more probable as an event that could occur, regardless of whether that was, like the sound that you heard. These are things that we know from our previous experience are events that are more likely than the others, more probable than the others. Okay, so this is where Bayes' rule can be used. This is where the Bayesian theorem can be used because we can now use these pieces of information, the likelihood, the prior, and the evidence, to determine what the best inference would be from our evidence. And the best inference is the one with something that's called the posterior probability, and it's shown on the left-hand side of that equation. The posterior probability is calculated for each one of your hypotheses, and then using the product of the likelihood and the prior probability given the evidence, you can get a figure for that. So in our example, we'd probably say something like, if we actually run the numbers through these, that the football kick or something could be the best inference, combining the likelihood and the prior. But the important thing, and this is like the key thing really, I think for predictive processing, is that Bayes' rule tells us that we have to update our posterior probability of each hypothesis if we acquire some new evidence. You have to recalculate the posterior probability. And in our example, say there was some new evidence, so you could hear your neighbour calling your name. You would then quickly re-rank your hypothesis, and the posterior would change. So there's these different elements of the Bayes theorem are important in predictive processing. The prior, the evidence, of course, we need more evidence, and then using these to create posterior probabilities. Okay, so I'm going to move on to something a little bit different, but related, which is prediction error. Now, prediction error is, I know I said almost everything that this is the core part of predictive processing, but prediction error is really the core feature of predictive processing. And it's the mismatch between prior expectation and reality. And another way of phrasing that is to say that prediction error is the difference between a model and the data. I'm trying to show that there with my little diagram. If there's a difference between the model or the prior expectations and the data, the sensory information coming in, then the difference is the prediction error. And the central idea in predictive processing is that the brain is constantly trying to reduce prediction error. That is the key thing that the brain does. And Jakob Howie goes as far to say is that it's almost the only thing that the brain does. Although I'm not sure I completely support that. But it's saying that it's a very, very important part of perception and action. So yeah, in reducing the prediction error, by reducing the difference between the model and the data, you can make better, more accurate inferences about the causes in the world. And this can be done because the predictive error can be used to inform a model and change the model, so the model changes, so the model can better match the data. So it's this active element that we're talking about. The brain is making predictions, it's receiving information, it's revising its predictions to match the data. Okay, so I'm going to leave it there for now, and then in the next video I'm going to talk about how this prediction error can be used in what's called the perceptual hierarchy, and have a little look at sort of how this might work on a more concrete neuroscience level.